Good afternoon, everyone. My name is Hunyady. I'm going to have a talk on NGINX Proxy used within Istio Services Mesh. And I'm the product owner. And I will be joined on stage by Seo Chang, who's the chief architect for this product. He'll be doing a demo for us. OK, so let's get started. Before I get started, I'd like to ask a couple of questions, though. How many of you are familiar with the services mesh? Show of hands. Oh, that's OK. How about Istio? Any of you have heard of Istio? 1, 2, 3. Oh, that's a fair number. All right, great. Well, thank you. That helps. All right, so I'm going to initially, this is the agenda. I'll speak about the evolution of microservices and what I perceive as the new stack. Then I'll talk about the role of the services mesh briefly for the ones that actually haven't run across it yet. Then I'll do a brief intro on Istio and talk about how NGINX and Istio will work together in giving you a services mesh for enterprise. Maybe I should call it an enterprise-grade services mesh. Then we'll do a demo that Seo will be doing for us, and I'll talk about roadmap since we have several. We're going to deliver this in several phases. All right, so let's get started. So if you look at, you might have seen this slide in the morning, and I'm trying to set some context with regards to the iteration of the applications and the transitions it has gone through from cloud servers in the 1990s to 3-tier apps, and then from then on in the 2000s to Web 2.0 applications. And with the evolution of container technology, what we're seeing now is the next transition towards cloud-native apps. If you look at cloud-native apps, it's all about, really, microservices. And they are defined by having small, loosely coupled workloads that have a well-defined API. They are portable, and they communicate with each other through a networking layer. This is all nice and great for developers, that they have the ability to use any infrastructure they like, since they're portable. They can easily move from their laptop into the cloud. They can use their favorite programming language, which may be C, Go, Java, so forth. And they have the ability to work on smaller workloads, so you don't really have to deal with the big monolith type of applications. But there's a downside. And the downside is that we're trading some of that complexity to the IT operator, which have to deal with deploying all these workloads across the ecosystem, across the data center. You may deploy 1,000 of them, or maybe 1 million if you're Netflix. They just announced that they hit the 1 million mark of services deployed on their network in April of this year. And it's one thing to do it in one data center. It's quite another to do it in multiple data centers and across geographical locations. Or when you want to get the same type of reliability, which you've seen before, the same type of troubleshooting capabilities, which you've seen in the 3-tier apps. As a matter of fact, Gartner announced that by 2021, about half the worldwide enterprises will move from cloud first to all in the cloud, which gives us about 4 years. Not a big deal, right? When you think of other transitions, in particular the one to virtualization, it took about 10, 15. But there's some good news. I mean, if you look at this, where this area is heading, a lot of companies and a lot of vendors in this area are building innovative solutions in the space. And let me talk a little bit about new stack. So if you look at cloud-native apps and microservices, you may think, oh my gosh, service-oriented architecture all over again. It's becoming cool, right? I would argue that that may be the case, but it's quite a different type of environment. It's no longer services bus related, but it's more built on orchestration layers. So if you look at this new stack, it has several components. First one is really the packaging, which is, I would argue, that's a pretty well-solved problem by now. Docker has done a pretty good job in providing you the portability you need and the ability to push polyglots within your system. And they've done something very interesting because in about 2015, at the end of 2014, early 2015, CoreOS announced that they have their own container technology, which was Rocket. And then Red Hat also announced Atomic. So what Docker has done, they decided to create an open container, OCI it's called. I forgot what the last letter is. I should look it up. The open container interface, infrastructure, sorry. And then what they've done is they brought all these companies together and provided their version 1 specification, and are trying to make sure that the packaging stays uniform and is going to be across all enterprises rather than become just a Docker-specific packaging. The next layer on the stack is the orchestration. Once you figure out how to package, once you figure out how to get your workloads into testing, you have to deal with orchestration type challenges. And those are, how do you take containers and assign them to compute? There are really 3 major vendors there, maybe 4 if you consider HashiCorp. So you'd have Kubernetes, Mesos, Docker, Swarm, and Nomad. I would argue that with about 40% of the market, Kubernetes is doing a good job in trying to standardize that orchestration function. The next layer, as Gans mentioned this morning, it's interconnectivity in between services. As you might have noted, when you're deploying containers, networking containers together is not a trivial task. And then it's even harder to actually secure them. So this is where the services mesh connectivity comes in. And I'll talk a little bit more about this because it has a lot to do with Istio. And the last part of the platform is really the application platform. And that's where you bring in the policy layer, the workflows, where you want to deploy applications across multiple environments. And that's where the controller, which we announced this morning, those are the type of problems the controller wants to solve by giving you workflows, giving you policy, giving you role-based access. And some of the issues that OpenShift is also solving, from giving you the ability to set up access control across your environments. So let's take a closer look at the services mesh. So what is the services mesh? Services mesh is a uniform infrastructure layer for service-to-service communication. It utilizes lightweight proxies, and it can be deployed typically in 2 flavors. It may be deployed as a side-by-side with the application. And if you look at this diagram, it may look familiar to you, as it is our reference architecture, Dai by Christensen, who I see him here in the first row. So this was built by us about a year ago, and some of our customers have tried it. It gives you the ability to run your proxy functionality side by side as a process, side by side with application level. And another implementation of that is done through services proxy. And that's the approach that Istio has taken, which I'm going to describe in more detail in the next set of slides. So why is services mesh required? It gives you a consistent way to deal with routing rules across the ecosystem, across various applications, security concerns, to make sure that only services that are supposed to communicate with each other will communicate, resiliency, have load balancing functionality, and work together with a service discovery protocol for services to come up, and when the services disappear, you're able to age them gracefully. And monitoring. You'll have the ability to do end-to-end monitoring by tracking when a packet traverses the network. And if you have multiple services that are chained together, you're quickly able to identify where that service fails. Right, so what is Istio? Istio is an open platform that provides a uniform way to connect, manage, and secure microservices. It was introduced by Google in collaboration with IBM and a series of other vendors. It was introduced only in May 23rd, 2017, and it's currently in alpha it's 1.6. Google anticipates that they will come up with the 0.2 sometimes this month, towards the end of the month. And they have a website they put up. There's a lot more information there. It has multiple layers, which I'm going to talk to you about. Right. So what is Istio? It offers you a control plane within Istio itself. So if, as I mentioned in the previous slides, there are two approaches that you can deploy a proxy. One way is through a sidecar proxy, and the other one is integrated. What Istio has chosen is to give a sidecar proxy, which is transparent to the application, but it is deployed on top of a Kubernetes environment. So each service that is deployed by Kubernetes will have a proxy side by side with it. And then what it does, it enables the application services to communicate with each other transparently. So the traffic that moves from one service to another, it will patch through to the sidecar proxy, and then they're able to communicate with each other without the application being involved. And it also takes the identity of the application. And why is that important? Because you can do some really interesting things with regards to security. By taking the identity of the application, you can set up things like MTLS, like mutual TLS, where you would authenticate both the client and the server, or both sides of the services, so you can ensure that only services that should communicate with each other will. And then it also does things like certificate authority automation. It enables you to rotate certificates, so you don't have to, that's no longer a manual operation. So if you look at the Istio, there are really three main components. It's on the pilot side, where you have the configuration for the routing domain and plugin into the service discovery. Then you have Mixer, where it does three things. In a sense, it makes sure that services that should communicate will communicate. It does monitoring, and it also does quota management. And it has authentication, which I've already mentioned. So where does NGINX come into play? I think that's kind of a giveaway. NGINX will be represented in this diagram by becoming the sidecar proxy in the Istio environment, which gives you the ability to get best-in-class features that you know, which from routing to load balancing to circuit breaker capabilities, caching, encryption, and more importantly, you have the ability to build your own custom modules, third-party modules. You can bring in authentication mechanisms of choice. You can bring in even dynamic language supports, like if you have Lua scripts or Engine scripts, they can now all of a sudden be integrated in an Istio-like environment. And we do have a roadmap that we're going to go through as we're iterating through the Istio deployment. On one side, we have Unit that we announced this morning. That gives you the ability to take the sidecar proxy and integrate it side by side with the services. And that there are some performance improvements for that. And it gives you the ability to deploy one component instead of two. It gives you better portability. So, as you're probably aware, within Kubernetes environment, there are pods, but pods don't really exist within a Docker Swarm environment, or maybe within a Mesos environment. So with having the unit component that does the services mesh function, as well as the application serving function, you can easily port from one environment to another. And on top of that, you're going to have the controller that gives you the ability to control your workflows. Because while Pilot enables you to set various routes for your application, for blue-green and for AB and for canary type of workloads, you need a high-level abstraction that gives you the ability to map applications together, write metadata around it, and also maybe move those applications from one cloud to another or from one environment to another. So that's all I had to say about this. And I'm going to ask now for Seo to come up and show us a demo of Istio and NGINX in action. We will be running Kubernetes, Istio, and NGINX together. So, Seo.
All right.
Welcome.
Thank you, Ajay. So this is the same reference app called Bookinfo app that is on Istio project. So this is the same reference app without any modification. And this is a typical a microservice application. So it has ratings services written in Node. It has details service page written in Ruby, and it has reviews services written in Java. So one thing you notice is that on the reviews, it has 3 different versions of the services deployed. And then finally, we have a product page that consolidated all the pages together. Now let's try to run this app. Running on a Google Compute Cloud, and we have 6 nodes running. And the first thing we need to make sure is that we have to make sure that Istio is installed. So for the sake of demo, okay, so we have the Kubernetes, the Istio, the control plane installed. So we do have ingress and egress part of the Istio. We have a mixer and a pilot components. And we do have 2 optional components called Prometheus and Grafana, which is to show the traffics. Okay. So the first thing I'm going to do is to actually deploy this app. Go here. Okay. And this is the same app that is on the Istio demo site. So let me just kind of show this. Okay. And this is the Kubernetes descriptor for deploying this app. So we do see here deployment for details. We do have ratings. We have here reviews. And you can see 3 different versions of the ratings here. And we have finally, we have the ingress description for this app. Okay. So let me now deploy this. Okay. Now, what happened is that in order to deploy this app, we for this version we are wrapping this with our utility rewrote. What we'll do is inject the sidecar for every part for the service application. Now, this is what we have to for the 0.16 of Istio. 0.20. The Istio is moving to what's called initializer, which will avoid for doing this. And what all this does is just wraps this extra configuration and just pass to the Kubernetes deployer. So let's just go, okay, deploy this, okay, and then let's look at the pod, okay, and you can see that this is deploying this. Okay. Now, while it's trying to get the port for the ingress, which may take a little bit of time, let's go open. And okay, now that shows up. Now let's go and open up Grafana, which is one of the optional components that Istio has. Okay. Okay. What the Grafana is doing is displaying a metrics from Prometheus, which is interface to its adapter for a mixer component. And this Istio is designed such that you can plug in different adapters, like a New Relics, or even maybe ladder or amplify. Okay. So let's go and make sure we have the service applications running. So we do see a product page and Prometheus, the ratings and details. So let me just get the ingress port here for that entire application. Page. Okay, so application is showing up. Let me go and make sure I refresh it. All right, there we go. So now the product page is showing up, and Now let's go back to the Grafana. Okay. Let me go here. Right. Now let's go refresh. And you can see the traffic data is coming out. So what's happening is that as the traffic hits the product page, the NGINX is taking those metrics and send it to the mixer, and it goes to the parameters, and it's now showing on the Grafana. Okay, and you can see that it's showing different services. So we are showing a product page, reviews. Okay, and not only that, but it's displaying a track for a different version of reviews. Okay. Now, one thing notice is that because we're displaying 3 different versions of reviews, so if I go and refresh these buttons, we have a red version, we have one with no ratings, and one with red ratings. So we have 3 different versions. Okay. So now, of course, this is not when initially we want to do is. So let's show the use case for the where we're actually going to control the traffic routings. Okay. So instead of showing 3 different versions of ratings, we want to say that we want to deploy version 1 of the reviews. Okay. So what Istio gives is a way to define the policy that says you can route the traffics. And the first use case is to route to the first version. So let me gonna show you route to all version 1 YAML file. Okay. So this is a specification rule that says that we are for all the services is route to the version 1. Okay, so we do. So the way, and then now we're using Istio tools to deploy this. Okay. Yes, let me go bring this one, how to see. There we go. Now rules display. Now if you go back and display, voila. So in that case, what happened is that we actually deploy a new configuration to NGINX, and only the version 1 of the review services display. Okay, so that's basically based on the very simple rule. Now the second use case is that we're going to display based on a content rule. Okay, so that's the, let me go and, okay, reviews test. So this is a second case where if user happen to user JSON is login, we want to display a version 2 rather than a version 1. Okay, so what we're doing is basically this is a rule set. If you see the user JSON in the cookie, we're going to route the traffic to the version 2. Okay, so we're going to do the same here. Yeah, let's see. Oh yeah, it's hard to see from here. Okay, route to. Okay, test 2 here. Okay, so now I go back here. Have sign in. Now we type in JSON, some password. Okay, So it's displaying a version 2 only for that specific user. Now, if you go sign out, okay, right there. Okay, so going to the version 1. Okay, so now let's see how this is implemented. So what we're going to do is going to look at the pods. Okay, so let's look at the pod for the product page. Okay, describe pod. Okay, so let me do this one a little bit again. Okay, so this is a pod for the product page. And as you can see, we have 2 containers. So one is the first product page, which contains the application code. And then we have a proxy. Okay, so this is what the NGINX is running. And this proxy is inject for every pod. So if you look at here, reviews, so this will be running on every pod here, NGINX running. Now, let's go and inspect the proxy container for the dev pod. Let me see. So here, let me look at this one here. Okay. So what we're going to do is we're going to just run a Kubernetes exec to inspect the pod here. Okay. So here. Now, if we run this one here, it's running NGINX, and this is the NGINX open source version. Okay. And if you go to NGINX, let's look at this one here. And you notice that this what we've done is that we retain basically a custom module called Mixer. And what this custom module does is take every request response set and send it to the Mixer, the control panel. And you can see on the configuration here that we have a server. So it's sending to the Istio, the control plane, and what the port is. And we are also sending, as part of that, we're sending the metadata information. And this is actually making a gRPC call from these modules to that Mixer control plane. That's the main configuration. Now, if we go to here, now to the service configuration. So for what we're doing is that we're actually pulling the service discovery information from the pilot part of the Istio and generate this configuration dynamically. So every time there's a new service registered or deleted, we generate this configuration. So let me just quickly go short here. Yeah. Okay. So we are seeing here for our product page. We are seeing here, this is for our ratings. And one thing you notice is that they all listen to the same port. So what happened is that we're actually routing every outbound traffic to the same port using an IP table. This is the same approach that Istio, other proxy that Istio use. And then we are dispatching based on the service hosting. Okay. And each one, and so we are basing on the service name of the port, their internal IP address in the Kubernetes. Okay. And we are also sending the additional metadata as a part of this Mixer metadata. And this is just a regular NGINX configuration, so there's no magic here. Okay, So, and then this is simply the configuration for that rule for dispatching this rule based on the user. And we are transferring that into just regular NGINX configuration. Okay. Right. That's it. Ah, yeah. Yeah. Thank you.
Okay, so we have a couple of more slides that we're going to go over, but I think what Istio has demonstrated is that NGINX makes quite a capable proxy within an Istio environment. We've actually have several components that we plugged in into as part of the Istio environment. We have a plugin which we bring into NGINX to communicate with Mixer through gRPC. We also have an agent that enables us to proxy all the traffic that comes into the service through our engine. So it goes in, then it's funneled through the services engine that we've provided, and it goes up in the service. So all traffic it's pretty much transparent to the application. So you don't have to make any changes to the application. You deploy the application as you would in a Kubernetes environment, and then you're making changes to traffic routing without really impacting the bytes of the application itself. So we're still trying to figure out where. It's been a really interesting setup, so we were not able to get everything to mirror. So anyway, what we're trying to say is that, okay, if you put in presentation mode,
I got it. Yeah.
is that this project is available on GitHub today. We just open sourced it, so you can play around with it yourself. It comes with instructions. And then in terms of the NGINX roadmap, as we said, it's in tech preview today. We have it available on GitHub. It's at github.com/NGINX. This is our new product name. And then we're going to have it available in beta. At that time, we'll publish more than the container. And we're going to do that with Istio 0.2 because there are several components that will be changing within the environment, and we'll also add auth. Then towards the end of October, we'll add the ingress controller as part of this. So you'll be able to have a full chain of information, and you're going to have full visibility across the ecosystem. And last but not least, we have a bunch of future enhancements we'd like to make, bring in gRPC on the upstreams through NGINX, and then we'll integrate NGINX Plus support as well as unit and controller. So we are a bit over time here, so I don't think I have too much time for questions. In conclusion, we'd like to leave you with a statement that NGINX has joined CNCF, and we are partnering with Istio to build innovative solutions that help enterprises transition to modern microservices architectures. And the project, as I said, it's available on GitHub. And thank you very much. Are there any questions? So the question is, what's the difference between API gateway and services mesh? So when you think of API gateways, you're dealing with high-level abstractions when you're assigning different type of authentication layers, and it typically has to do with the traffic coming to your network. Services mesh deals with service-to-service communications. It provides you security, maybe it provides you mutual authentication. Within API gateways, typically one-way authentication. You have a SSL certificate and you authenticate the client. Typically API gateways come with a control plane that enables you to provide ABS for multiple types of applications. Services mesh and Istio itself is more about inter-service communication and abstracting applications from each other. So they probably have different functions. All right, so I guess if there are no other questions, thank you very much, and time is on. Thanks.